Find the area under the curve y is equal to 1 over the cube root of x minus 2 squared from x is minus 3 to x is 6, giving your answer in exact form. Okay, so if we sketch the graph, it would look like this. The required area is a bit shaded in blue. Now, the important point here is that the line here, x is equal to 2, is a vertical asymptote. So the problem is here and here, these go on up until infinity. So how do we actually find the area? So the required integral is from minus 3 to 6 of 1 over the cube root of x minus 2 squared. The function is discontinuous at x is equal to 2, but we might be able to evaluate the area. Again, this is going to be called using improper integrals. So we can attempt to evaluate this using the following method involving limits. Remember, it doesn't always work. What we need is it to actually converge. So the integral of from minus 6 of 1 over the cube root of x minus 2 squared, we split it up into two separate integrals. So we split this one up and this one up. So this will be, the first bit here will be the integral from minus 3 to 2, the value of the asymptote of 1 over cube root of x minus 2 squared dx, plus from 2 to 6, of 1 over the cube root of x minus 2 all squared. Okay, so we just write that line out again. Okay, so now doing the limit as a goes to 2, replacing the limit here, the 2 with an a, so the same function, same to the other one, plus a going to infinity, but replacing this with a and this with a 6. And we work these out separately and we can add them together at the end. Okay, so note, if you were to integrate x to the minus 2 to the minus 2 thirds dx, which is what this is, you're going to get 3x minus 2 to the 1/3 plus c. So this now becomes the limit as a goes to 0 of this. We're going to write the cube root of x minus 2, and then the limits minus 3 and a I put here, plus the limit as a goes to 0 of 3 cube root of x minus 2 from a to 6. So this is going to be the limit as a goes to 2 of 3 times the cube root of a minus 2, substituting in minus 3, minus 3 cube root of minus 3 minus 2, plus the limit of 3 cube root of 6 minus 2 minus 3 times the cube root of a minus 2. You can actually take the cube root of negative numbers, so you need to remember that. So the first bit will remain the same. This next bit here will become minus 3 minus 2, which is minus 5. And minus times a minus will make it plus 3 cube root of 5. And here we're going to get the limit of 3 cube root of 4, 6 minus 2 minus this, minus 3 times the cube root of a minus 2 squared. You just need to keep your wits about you. Now, if a was going to be 2, this a minus 2 will converge towards 0. So the cube root 3 times the cube root of a minus 2 will also go to 0. So this becomes 0, and this will become 0, and this will just tend to 3 times. So this is going to converge 3 times the cube root of 5, and this here we'll just need to add to it 3 times the cube root of 4. We could take out a common factor, because we were asked to leave our answers as exact. So the final answer will be 3 times the cube root of 5 plus 3 times the cube root of 4. Now I have got a GeoGebra app to go with this video, which will be in the notes of the video, the link to it. So if we look at the GeoGebra app, here we have this point here, we have our area here, the area here. If we click on the link downstairs here, click on the solution, you'll get the solution. Okay, the good thing about this one, of course, is that you can change the limits, and obviously the answers will change as well. So, and also you can change the value of k, so you can move k to a different value. K is restricted to integer values, but you can change the limit. Okay, it doesn't matter, you can see it's going to converge. Okay, so I hope you find that applet useful. It will be in the notes of the video. Okay, so it's been a video to show you how to use improper integrals to find areas. This is a more harder example where the function is discontinuous. Please remember, you can't always actually evaluate the limit, therefore sometimes it will become undefined. I hope you've understood, and I thank you very much for watching.